Integration is an important topic in analysis. This series is about Lebesgue's criterion for Riemann integrability. A Riemann integrable function can have an infinite number of discontinuities. For example, Thomae's function t of x equals 1 if x equals 0, 1 over n if x equals m over n not equal to 0 in Q is in lowest terms with n greater than 0, and 0 if x is not in Q is discontinuous at every rational number. T is integrable with the integral from 0 to 1 of t equal to 0. To prove this, given epsilon greater than 0, we need to construct a partition p sub epsilon of the closed interval from 0 to 1, such that the upper sum of t with respect to p sub epsilon minus the lower sum of t with respect to p sub epsilon is less than epsilon. The lower sum of t with respect to p equals 0 for any partition p because there is an irrational number in every interval. Now consider the set d sub epsilon over 2 equals the set of x such that t of x is greater than or equal to epsilon over 2. This set is finite because there are only finitely many positive integers n such that 1 over n is greater than or equal to epsilon over 2. So for each x sub I in d sub epsilon over 2, let y sub I be the maximum of x sub I minus 1 and x sub I minus epsilon over 6, and z sub I be the minimum of x sub I plus 1 and x sub I plus epsilon over 6. Then p sub epsilon equals the set of 0, 1, union the set of y sub I, union the set of z sub I, is the partition of the closed interval from 0 to 1. By considering the upper sum over the subintervals containing elements of d sub epsilon over 2 and those that do not, we can show that the upper sum of t with respect to p sub epsilon is less than epsilon. Hence t is integrable. As another example, consider h of x equals 1 if x is in C, and 0 if x is not in C, where C is the Cantor set. H is discontinuous at every point in the Cantor set, which is uncountable, but H is still integrable. To show this, we construct a finite collection of open intervals O sub n, such that their union contains C, and their lengths sum to less than epsilon. Then using the endpoints of these open intervals to partition the closed interval from 0 to 1, the upper sum of h with respect to p sub epsilon minus the lower sum of h with respect to p sub epsilon is less than epsilon.